Um, okay, so the first thing I'm seeing is in terms of this graph, when there isn't a solid point on the end like that, you're supposed to assume that it goes on forever. So I think there's a few of those that do that. Yeah, like this one up here, same thing. The range of the function. Just while I'm right here, I just noticed this. So when you're using infinities, it always, so this was number 11, the last part of that. The range is right, but for infinity, you're always going to use the parentheses, so that's the only thing you need to fix up there. Anyhow, coming back to this one, so then to find the domain of this function, we want to think about the x values for that. So the domain is going to be all the values of x that this can possibly be. And we want to go from the farthest point on the left to the farthest point on the right. So the farthest point on the left right there is going to be that -4, and the bracket is good. We want to use a bracket because it has a solid dot. And then this thing's going to go on forever and ever. It's going to go out on the positive axis on x forever, and it's going to go up forever. So that's going to affect our domain and our range. So this one should go from -4 to infinity. Let me just pull that up so you can see it. Again, the -4 right there is going to have a bracket because of the solid dot. Infinity, always a parenthesis because you can't get there. So then next up we got range. The range is going to be from the lowest point on the graph to the highest point on the graph. So we're always writing these from small to large. So in terms of domain, it goes left to right. In terms of range, it goes from low to high. So the lowest point on this graph appears to be right here. And with range, you have to be careful to remember that you're looking at the y values. So that 5 doesn't matter. That's where it happens. But the lowest point on the graph would be -6. And whenever there is actually graph there, you would use a bracket, because if I asked you where's the graph equal -6, you'd tell me right here, and it does actually equal the -6. There isn't a hole there or anything. So that part was great. And then I think the part where this goes up forever was the only part that you missed there, and that's again going to be that positive infinity with a parenthesis. What are the x-intercepts? Give your answer as coordinates. Okay. There's one right there. Oh, you're fine. You're missing the negative on that one, so it should be -1, 0 rather than 1, 0. And then give the zeros. So once you turn that into a -1, then that will be fine as well. And let's see. Give the interval of x such that g of x is less than 0. Okay. So g of x being less than 0. So this means where are the y values less than 0? And it's going to be the opposite of this right here, because that's where they're greater than 0. But where the graph is under the axis. So coming back up here, and was it equal to, or sorry, let me take a peek, not equal to. Okay, so for here we have to exclude zeros and anything positive. So this is going to be the y values, the graph is going to be under the graph, and the y values will be less than 0 from -4 to -1. And then again from -1 to 12. And that's because that's all the places of the graph is below the axis, and we have to exclude that point right there, because at that point it's actually 0. So let me show you how that's written down there. So basically we're saying everything from -4 to 12, but we have to exclude the -1. So the way that we would write that is right here. We can go inclusive on the -4, and then up to and not including -1, because we want to exclude that point, and the union over to the other side, pick back up at -1, and then that's out to 12. And then the 12 we're not using a parenthesis on, or we're using a parenthesis because we don't want to include that point. So think of this as kind of a dot right here going to an open dot where we're not going to include this. We're trying to include from there up to there but not including, and then all the way out to here. So again, that's what that would look like. Hopefully that helps.